Microsoft Research is hiring. Watch this video to hear what it's like to work here for members of the team, including Peyton Jones. And I'm delighted we'll be joined later on by Head of Product for Microsoft Excel, Brian Jones, and he'll be telling us about the new LAMBDA function in Excel. I'm Andy Gordon. To me, POPL feels like home. I first published at POPL back in 1996, and I was the PC chair at POPL 2017. We at MSR learn a lot from POPL, and I think we've made some strong contributions. I'm thinking about the Z3 SMT solver that powers a lot of tools in the PL research community. I think about F-star, lots of papers from F-star at POPL, or Flashfill, it was first presented at POPL. Microsoft Research is 30 years old and has established itself as one of the great international research organizations. Come here to advance the state of the art in research and to collaborate with product teams that build products that are used globally. Each year, we welcome PL interns and researchers to our labs, especially in Redmond, in Bangalore, in Cambridge, and Beijing. Microsoft Excel launched in 1985 and is now core to the world's decision-making. The Microsoft Excel team collaborates closely with Microsoft Research. Ben Zorn at Microsoft Redmond and Dongmei Zong in MSR Asia have great collaborations going with the Excel team. And so do we in MSR Cambridge. And I'm happy that this year's POPL video is being presented by members of the Calc Intelligence team. We are a collaborative team with expertise in programming languages, in machine learning, and in human-computer interaction. We are on a mission to bring intelligence to end-user programming, in particular looking at how end users program with formulas in spreadsheets. CalcIntel is in partnership with the Microsoft Excel team to transform the formula language into a full-fledged programming language. We're delighted that the outputs from this long collaboration are starting to appear in the product. 2 years ago at POPL in 2019, we talked about two features, dynamic arrays, where we can have a whole array sitting in a cell, and entities, where you can have a record sitting inside a cell. This year, though, at POPL, we're delighted to announce that Excel now has both let and lambda. That's right, you have full higher order functional programming inside the Excel formula language. So, what does lambda look like in Excel? It's a new function in Excel's formula language that lets you define a new function from a formula. For example, head is a lambda that takes a string and returns its leftmost character. str is the input argument, and the if formula is the body that determines the answer from the lambda. We can give a name to a lambda function, like head or tail, so it can be used in other formulas. Our third lambda, reverse, is a string reversal function defined recursively in terms of itself. So why should customers care about lambda? Remember the 3 R's. We can name pieces of logic so that formulas are more readable, and the logic is more reusable. Instead of copying a complex formula many times, we write it once as a lambda and call it many times. Any mistakes can be fixed in just the one place. Finally, recursion means that the formula language is Turing complete. In this video, you'll hear from different members of our team about future concepts we're working on in the lab. And I'll also be speaking with Brian Jones, Head of Product for Excel, and asking him about his perspective on Excel as a programming platform. But first, over to Jack, who's going to give us a demo of programming with Lambda in Excel.
Hi, I'm Jack. I'm a researcher here at MSR Cambridge, and what I want to talk to you today about is how in Excel it is now possible to build real, full-fledged programming experiences. This is the Lambda Playground. This is an Excel add-in, and it's built using publicly available technology. So we've taken the text editor from Visual Studio Code, that's called Monaco, and we've dropped that inside the add-in. And then we're using the Excel JavaScript API to synchronize the code in the text editor with the name manager. So the name manager is just Excel's way to name a formula that can be then reused in another formula and used within the grid. So here I've got a couple of basic definitions, like a factorial function. I can write this in the code editor, and we can see that it gets synchronized with the name manager. So now I can use this in another name. I can call it from a cell in the grid. With this, we can now start to build some things that look like real programs. Here I've got a tiny contract library. So a contract is just a way to assert that a value satisfies some invariant. So it could be that a value has a particular type, or that we call a function with the correct arguments. So let's start by defining a typeof function, which is going to take a value and return a nice description of its type. Excel already gives us a type function and a switch function, so all we have to do is line up these type codes with the nice description for the type. Once we have this, we can now start to write some basic first order contracts. So we're going to write this function here that takes a predicate, and it's going to return a function that checks whether the value satisfies the predicate, and if it does, it returns the value back. And if it doesn't, it's going to return this error, this pound value. But now that Excel is a real higher order functional programming language, we also want higher order function contracts, and we can do that too. This is a simple implementation of the wrapping technique from Finler and Felizen back in 2002. And what it's going to do is it's going to take an input contract and an output contract. It will take the function that we want to wrap, and it's going to give us back a new function that each time it's applied, it's going to check the input, it's going to apply the function, and then it's going to return the output with the output contract applied. Now this is pretty cool, but we think Excel and lambdas start to get even more interesting when you combine them with dynamic arrays. So dynamic arrays are just the capability in Excel where when a formula in a cell computes an array, that array is going to spill out of the cell into the surrounding grid. And so using a single formula, you can now control the content for a range of cells. So what might we do with this? Well, here I've written this calendar function. It's going to take a timestamp, and then it's going to take an optional boolean that says whether we want to mark the day in the calendar or not. And it's going to return an array that represents the calendar. And because of dynamic arrays, this is going to spill into the grid. So now I can create a calendar anywhere in my spreadsheet. What if I want to create a calendar for the whole year? Well, I can do that too using a bit of recursion. So here I've got this lambda called vcat, which is going to vertically concatenate two arrays. And I'm going to recursively call that to create a calendar for each month, and therefore create a calendar for the whole year. Behind the scenes, vcat is using this function arrayMake, which allows us to generate an array using a lambda. So it takes the dimensions, and it's going to take a lambda, and it calls the lambda for each element in the array. We think lambdas are really exciting, and so do the Excel experts and influencers. So even within the first few weeks of lambdas being released, there were videos with hundreds of thousands of views on YouTube. There's really big space to explore how spreadsheets and higher order functional programming can coexist and produce a unique experience. But before we talk more about our research, here's Simon to tell us about some of the amazing things we've done and how this relationship got started.
When I first joined Microsoft 22 years ago, my first question was, how can a functional programming researcher have impact in Microsoft? So I soon zeroed in on Excel, because Excel's formula language is precisely a purely functional programming language, and moreover, it's more widely used than any other programming language on the planet. Put that way, it sounds pretty exciting, doesn't it? But Excel's formula language, considered as a programming language, is terribly limited. Two things stand out in particular. Number one, you can't define new functions. You can only write formulas that call the existing built-in 600-odd functions that are part of Excel. I don't really count writing new functions in JavaScript here, because end users just can't do that. Second thing, Excel's formulas mainly manipulate scalar values only, numbers, strings, booleans, and so forth. They don't really let you manipulate records and arrays, let alone nested records or arrays. So, in partnership with Alan Blackwell and Margaret Burnett, who are both researchers with extensive experience in end-user functional programming, we worked out designs for lifting both of these limitations. So, first thing, we wanted to let you define new, user-defined functions in Excel's own formula language, in fact as worksheets. Second, we wanted to allow you to define rich structured values, and in particular to make arrays into first-class citizens, including arrays that have arrays as elements and nested to arbitrary depth. And the arrays could be passed to a function or returned a result or stored in a cell, just like any other value. So in other words, arrays would become truly first-class values. And we published papers about both these ideas back in the early 2000s. Now, at that time, I was visiting the Excel team in Redmond a couple of times a year, and they were really friendly, they were receptive, they were encouraging, and we had lots of interesting conversations. But I learnt that Excel is like a supertanker. It has very high value, it has very large mass, and it's operated by a surprisingly small and heavily overworked crew. So it's not easy to change course. So on each release cycle, these cool new ideas that we've been talking about were on the list, but they never made the cut. So I had plenty else to do, so after a few years I just stopped bothering them. And then about 10 years after that I had reason to go back. I forget exactly why. And I discovered that one of the mid-level program managers I'd been talking to back in 2004, those friendly, receptive folk that I mentioned, had since been promoted to be the great boss of Excel. Result! So off I went to talk to my old friend Dave. And he was super enthusiastic. Suddenly we began to get senior executive level buy-in for some of these ideas, and crucially, Dave was happy to support applying engineering effort to it, and that in turn led to much more than just implementing a few ideas. It led to a rich partnership that is the subject of this video between a product team on a very established mature product and a research lab in Cambridge in England. So, in fact, things didn't work out quite in the order I expected. The first thing that landed in the product, about this time last year actually, turned out to be so-called dynamic arrays. And that was a really big step towards arrays as truly first-class values. The second thing that landed very shortly thereafterwards was called entities in cells, and that was the ability to allow a cell to contain a kind of record populated from an external database that can represent, say, something like a person or a city, and from which you can, in Excel's formula language, programmatically select or extract the name or population of the city by ordinary record selection. The next big thing, which came out just a month ago, is the release of LAMBDA, which you've already seen in Jack's demo. In some ways, it was a bit surprising that LAMBDA came first, because LAMBDA is full, higher order, first-class LAMBDA is a pretty geeky feature compared to simple first-order functions. But it landed first in part because it adds a lot of expressiveness, but it doesn't really affect the UI very much, and so it's an easier sell to land. But that's not all. There's a lot more to come, and next up we hope is going to be sheet-defined functions. That's functions defined as worksheets, and that's what Advait's going to tell you about next.
Hello everyone, my name is Advait Sarkar. You've just seen lambdas in Excel. A related idea, which Simon mentioned, is sheet-defined functions, the spreadsheet equivalent of functions or subroutines. You take a bit of grid that expresses the function you're interested in, nominate input and output cells, give it a name, and save it. Calling this function is like instantiating this bit of grid, substituting the arguments in the nominated cells, and returning the value of the output cell. An advantage of this over lambdas is that the function can be spread out over many cells with layout, comments, and formatting to help you develop the function. The problem is that SDFs only take arguments of a fixed length and can produce a single output. Now, most programming languages solve this by allowing arguments and return values to be arrays of any length. But spreadsheet users don't think in terms of arrays. Instead, they think of element-wise operations and then use drag, fill, or copy-paste to instantiate the array computation on their data. The array code for many functions is beyond the expertise of most users. Our intern, Matt McCutcheon, developed a solution that we call Elastic SDFs. For more details, please refer to our JFP 2020 paper. We analyze an SDF written out using a fixed length example and generalize it to work on inputs of arbitrary length. This is all behind the scenes, so the user writes an SDF using spreadsheet idioms such as drag, fill, or copy paste, but now it works on arguments of different lengths and produces the right outputs. So we're done, right? Well, not quite. We view programming language design as a research discipline whose goal is to create more usable human-computer interfaces And if our intent is to improve usability, we do need to test whether we have improved usability. So another intern, Judith Bohutz, designed and conducted a usability experiment in which participants created SDFs of variable length using both the elastic SDF technique as well as array programming. This became the first published user study of SDFs, and we believe the first user study of any kind published at JFP. As usual with user studies, we learned many things that we did not anticipate. The first thing was that elastic SDFs are not always a straight win. They're less transparent than array programming, so where the array program is easy to write, users preferred it. Users only preferred elastic SDFs when they couldn't construct the array formulas. The second finding was that SDFs, elastic or not, do not address an important type of reuse in spreadsheets. This is where the user wants to see the layout, formatting, and intermediate values that make up an SDF's definition. Because SDF calls, like functions in traditional programming languages, elide the underlying mechanics of the function, they are more opaque, appear less trustworthy, and even less useful in some cases where you want to edit different values in different invocations or edit part of the logic. Users' favorite solution to this type of reuse is copy-paste. In a pasted area, you are free to edit any values or formulas. You get all the layout, formatting, and intermediate values too. But there is no link between the copy and the source, so if the function needs to be updated or a bug needs fixing, the user has the tedious and error-prone task of uniformly editing every copy. We can mitigate this in many ways, including maintaining a database of paste actions and offering to help the user update all copies. But we took an alternative approach, which we call gridlets, which we worked on with intern Nima Jaharizadeh. Here is a lightning quick overview. A gridlet is comprised of an area of grid that you want to reuse. In this case, we're giving it a name, Mortgage Repayment Calculator. Once the gridlet is created, it is available for you to instantiate. You can instantiate as many copies as you like, each having different values for their parameters. You can edit the original, and those edits uniformly propagate to all the copies. Please refer to our CHI 2020 late-breaking work paper for more details. In our ESOP 2020 paper, we explain how to achieve this using just formulas and spilled arrays. We proved a direct encoding of the Abadi and Cardelli object calculus into our grid calculus. This is the first rigorous analogy between spreadsheets and objects, showing that gridlets are an object-oriented counterpart to sheet-defined functions. An analysis through the cognitive dimensions of notations, which is a PL design framework, helped us understand how gridlets fit into the family of reuse affordances that spreadsheet users need, including lambdas, SDFs, and copy-paste. So, to summarize our journey, we tried to make SDFs more accessible with elastic SDFs, discovering a further opportunity resulting in gridlets, a new type of spreadsheet reuse that uncovers an interesting correspondence in programming languages research. The moral of this story is that if you view programming languages research as being about human-computer interaction, then usability studies with actual people ought to form part of your research regime, not only to check whether your system actually has the effect you expect it to, but also to provide surprising and valuable insights that you could never have anticipated by yourself.
Hi everyone, I'm Carina, and I'm a machine learning researcher in the Calc Intelligence project. Today I'm going to give you a brief overview of some of our machine learning work. In the last decade, there have been tremendous advances in machine learning models aimed at enhancing the coding experience for both authors and collaborators. For example, think of your favorite editor and go down memory lane to reminisce how much our coding has changed. A significant contribution is undoubtedly due to intelligent features like code autocomplete that make us more productive and our code less error-prone. Now, type inference is a building block for machine learning applied to code. This task is about figuring out what the variables in our code represent. Are they integers, strings, or something else entirely? Well, once we figure that out, we can find and prevent potential errors or make suggestions, such as variable naming. But what about end-user programming in spreadsheets like Excel? Well, we need to redefine what types mean. Dimensions like time or currency, or more specific units like days or dollars, are known from previous research to be useful types for numbers in spreadsheets. Spreadsheet formulas support standard type-checking algorithms that assign unit types to numbers. Cell formats, like date or dollars, are akin to type annotations and enable type inference when present. Still, end-user programmers often express type information using ad hoc textual labels in cells, rather than using formats. Our work extends the state-of-the-art of unit inference for spreadsheets by using these textual signals in the grid, such as table headers or labels on cells. Our methods mix logic-based type inference with machine learning, and our dimension inference results are on par with human performance. Now, are there other types that we should consider? Well, spreadsheets can tell a comprehensive story about various concepts, and it would be great to have an AI storyteller. Many strings in spreadsheets, especially entries in tables, are identifiers for real-world entities. Public knowledge bases, such as Wikidata, are vast repositories of notable entities and facts about them. An example of a fact is that the entity A Dog of Flanders has the category movie from the 1950s. The task of resolving a string, such as A Dog of Flanders, to a knowledge-based entity is known as conversion. Conversion is important for Excel because it lets us turn a weakly typed string into a strongly typed record holding facts about the corresponding entity. Since a string could represent one of many entities, conversion is a form of type inference. In collaboration with Microsoft Asia and our wonderful AI residents and interns, we have built a machine learning system to convert whole tables, that is, to convert each string in the table into a corresponding Wikidata entity. Our system came second in the SemTab competition this year. Together, these projects look to a world of strongly typed spreadsheets. Knowing the units or dimensions of numbers and knowing the real-world categories of strings help us detect discrepancies automatically and enriches our spreadsheets with new information. But we can go even further and suggest new formulas, such as the dot notation, for accessing knowledge-based properties of entities, and even enrich Wikidata with extra information from our tables. Our team in MSR develops a vision of a world of strongly typed spreadsheets. It's not an official product plan, but as with lambdas and other features, we have a strong track record of influencing Excel to date. We have multiple meetings each week with members of the Excel team, and here is Andy in conversation with Peyton Jones, our product manager for Excel.
Okay, folks, here I am with Peyton Jones. We have a monthly call to liaise between the CalcIntel team here in Cambridge and Excel.
This regular sync that you and I have and the partnership between the Excel team and the CalcIntel team is so critical, because from our side, we have to think about all of the uses of Excel. And so oftentimes we're thinking more in terms of just the average end user, improving usability, improving the approachability of the product. And the insight that we get from the CalcIntel team around what it really takes to build a programming language, what are all of those constructs that you need to have something that's robust, right? So that what people build can last, is easy to debug, and all of the leadership that we've had from you all around the importance of things like data types, actually having, like, before every cell was essentially just like a string or a number. And folks like you and Simon have really helped us think about what are the other things that need to be added to really make this kind of all of the benefits that you get out of a programming language, right? And we're bringing that to Excel. And so we think that the past few years have really been pretty revolutionary for the product because of that thought leadership we've had from the CalcIntel team.
Thanks, Brian. We are particularly excited this POPL because we're able to talk to our researcher colleagues about Lambda in Excel. It's now been public for about a month. So what's your impression of how your customers are responding to Lambda?
Yeah, it's been extremely positive. This is the thing that's so fun about Excel, is that people are already using it to build very complex models and solutions, right? They are using it as a programming language, but they are hitting some of these limitations that have come in Excel. Data types was one of those, dynamic arrays, and now Lambda, where people can go and encapsulate logic to reuse. They have recursion. Excel is Turing complete. And we had overwhelmingly positive feedback. In fact, one of the things, typically when we roll out new features, we have a few different rings of the product that we roll them out through. And so the first ring is what we call Insiders Beta, and people can sign up to be in the beta program, and that's where they get the new features first. But usually when we roll them out, we kind of go in increments, like 10% of the audience, then 50%, then 100%, just so that we can test things out along the way. And we got a huge amount of feedback back around people that were frustrated that they didn't have Lambda yet because we weren't rolling it out fast enough. And it's actually caused us to reflect on whether or not for certain things like Lambda that's important like that, when we make that announcement, whether or not we should just go fully to 100% right away and use some of the other rings to do some of that validation that we were doing in the earlier rings.
Wow, that's a great story, Brian. So each summer, as you know, we have interns who come in and work on research projects. And sometimes these projects lead to papers, and other times they have a direct impact on the project. I love the story of Jack Williams, who's now a full-time senior researcher in our team. Jack did his PhD at Edinburgh with Phil Wadler, but then he interned with us, and we had this hackathon, the Calc Anywhere hackathon, that led to the first version of CalcTS.
Yeah, I mean, I think CalcTS was such a great example of we already had a really strong partnership between the product team and the research team. So as a result, the research team had really good insight into some of the key problems that we were hitting, even ones that weren't directly related to what we were working on. So we were primarily working on all of the stuff around Excel as a programming language, right? Like, so data types, lambdas, reusable functions, things like that, right? But also, like, because of that, you're also working with the full team. And one of the big challenges that we had was in our web application, every calculation had to do a round trip to the server, right? Even simple calculations, like you have some basic summation and you change one of the values, and then there'd be this lag. And the research team had already been looking at essentially a JavaScript-based version of Calc for some of the other projects, right, to help try and do some of the things around inference of types. And there was the recognition that we could go and take that code, put it into our web application, and we now have it for the vast majority of calcs, recalculations. We can do it just client-side directly in JavaScript. We still do it on the service to really maintain the true quality. I don't want to say quality, but like the actual trust in the calc. So it's the exact same calc model that's executing on the clients and all of that stuff. But then we do this kind of approximation on the client side, and almost all of the time it is right. But from the user's perspective, it's instant, right? And so it made a huge impact in just the experience of people, everyday people using our web application.
We were so proud of doing CalcTS and collaborating with you guys on that. And for Jack, I mean, it's a fantastic career trajectory. He came to us as an intern that summer. We persuaded him to stay on, and we did the first release of CalcTS about 6 months after the hackathon. And then he went back to Edinburgh, finished his PhD. That was really important. Came back to us as a postdoc, and that's gone really well. He's been doing research on units and various other things. And now he's recently been hired as a senior researcher in a permanent position. So great career trajectory for him.
Yeah, I feel like every year you and I are talking about the latest intern and how excited we are and how we go and find the full-time role for them once they finish up their research, right? It's been pretty incredible, the number of really strong folks we've had come through over the past few years.